see. This is the device. Right. So over the last few years, you'll see that deep learning has been amazingly successful. It's enabled us to tell what age roads in Kirikiriroa are, which has allowed us to find out how smug entrepreneurs are these days, and so many other things, sort of solve chess and go, etc. But the history of AI has not really been the history of AI has not been entirely neural networks. It's not been entirely machine learning. It's been a mixture of symbolic, and we've heard a little bit about that, and neural techniques. So what can we do to sort of retain and maintain the success of the sorts of symbolic things which have made humans so successful, and which have made computers so successful, but aren't showing up as much in the way that AI has been talked about now? What happened to it? So, what happened to this idea of applying knowledge stored in a use-agnostic way to solve new problems? I mean, to some extent, pre-trained neural networks maybe do that, and there are problems with transfer, but we can use it. But, it would be nice if these systems could use knowledge in the kind of way that human beings do, but with the flexibility and adaptability and trainability of neural networks. So that's what my lab tries to do. And we talk about knowledge very broadly, right? This can range from anything from mathematical logic, which is sort of how we used to think mostly in AI about knowledge, all the way through to symbolic forms such as poetry and song, right? They're not symbolic in the computational sense that we usually use, but they certainly are symbolic from the point of view of comparing them to the sorts of representations in, say, word embeddings used to find out how smug entrepreneurs are. So I'm supposed to be encouraging to entrepreneurs, but not today. Right, and I've had a history of doing research in this area of mixing symbolic and neural network techniques. I've sort of, throughout my career, I've worked on both symbolic and neural network types of systems, and now I think there's a real opportunity to push things forward. So in my lab, we're trying to do this. We're using essentially, usually neural networks, mostly neural networks, to solve the sorts of tasks which would traditionally have been solved by programs. So in multi-step question answering, we're trying to move beyond the current techniques, which are entity graphs, by having neural networks able to handle more complex knowledge representations, which are kind of like logic in the way they function, if not at all logic in the way they're actually written down. Moving behind just hops, just step-by-step reasoning, chaining things together, to doing more complex types of question decomposition and recomposition, and moving between, to question answering in low-resource languages, including, very importantly, Te Reo Māori. Right, so we're trying to, again, use neural networks to enable inference at scale. Inference is great, but I recently spent a couple of weeks trying to make answer set programming and inference system solve a simple problem in biology, and I kind of gave up in the end. And it's because it can't really understand enough about biology to make that problem efficient. So we're trying to treat deduction, abduction, and inductive steps and other reliable steps just as if they were parts of a game, which they really are. So symbolic logic is very similar from, I think, a computer's point of view to play a game like chess. And we're trying to take the techniques which have allowed computers to become so much better at chess than human beings that no human being will ever win a game of competitive chess again, right? And apply those to mathematical logic. And we've got several students working on this, and this is a collaboration with people at IBM Research. Trying to make interoperable symbolic representations. So representations which can be used by neural network reasoners across many problems. So using modern deep learning techniques to make representations which are effectively like logic, but which are not logic, and apply that to tasks in understanding legal documents, question answering, and very importantly, understanding biomedical texts and biological systems, because while AI is taking off now, biology is taking off as well. Freeing this inference from logic, so doing reliable inference on text, just as human beings can with some kinds of text, automatic production of these precise representations. So at the moment, to get precise representations like mathematical logic, you need a human, but humans are really terrible at this, right? Precise representations like those in scientific papers, we're really, really bad at this. It would be good if computers could help us to produce those representations. And lastly, we're doing some dabbling in more complex kind of phenomena like real memory, long-term, short-term, and intermediate-term memory, and phenomena like consciousness. And if you want to have a amusing conversation with me, ask me about that over a drink sometime. And lastly, we are trying to work on policy paths where this development of true AI turns out to be good for the humans and good for Aotearoa in New Zealand, and I think that will do. Thank you.